Hello everyone, I'm going to explain quantum physics part 2. Work function. What is the work function? The work function denoted by phi. It is the minimum energy required to remove an electron from a metal. The work function equals h multiply f naught. H is Planck constant, f naught is the threshold frequency. What is the threshold frequency? It is the minimum frequency which can emit an electron from a metal. So, if this is a metal, had a work function phi, when the incident photon has energy greater than or equal the work function of the metal, so photoelectrons can be ejected with kinetic energy. Now, so when the incident photon has energy less than the work function of metal, no photoelectrons will be emitted. Now, in the first case, the energy of incident wave or the incident light is less than the work function. The incident light has energy 1.77 electron volt, but the work function is 2 electron volt. In the second case, it is just greater than the work function of potassium. So now you can see photoelectrons emitted, but they are lazy without kinetic energy. In the last one, look at this. This is photoelectrons emitted with kinetic energy. Why with kinetic energy? Because the incident photon has energy greater than 2 electron volt, greater than the work function of the metal. Now we have very important equation. The relation between kinetic energy maximum and the energy of incident and the work function. If the energy of incident light is greater than the work function, so the photoelectrons emitted with kinetic energy maximum. This graph is very important. Join between kinetic energy maximum and the frequency. From that graph, we deduce many things. First thing, the slope of this graph represents the Planck constant. And the point of intersection with x-axis represented the threshold frequency. The point of intersection with y-axis represents the negative work function. We solve the questions from Future in Physics book. Okay, second semester 2020. Exercise 9. 5 electron volt will produce electrons with maximum kinetic energy. So kinetic energy maximum equals 3 electron volt. What is the threshold frequency? So we need F naught. Because the energy in electron volt and kinetic energy, so it's better to leave the same unit. What is the relation? The relation is that kinetic energy maximum equals E minus phi. This equation, all the units are units of energy. So we need to get F naught. F naught comes from what? From phi, because phi is the work function equals hf naught. So to get f naught, we need to get phi. From this, we can rearrange the equation. So phi equals E minus kinetic energy. E equals 5 minus kinetic energy 3 equals 2 electron volt. Now it's better to change electron volt to joule. The relation is that 1 electron volt equals 1.6 times 10 power negative 19 joule. So from electron volt to joule, multiply by this value. So the value of phi, it's 2 times 1.6 times 10 to the power negative 19. So the answer is 3.2 times 10 power negative 19 joule. Phi equals what? HF naught. So HF naught equals 3.2 times 10 power negative 19. From this we can get F naught divided 3.2 times 10 power negative 19 by H. The value of H, blank constant, 6.63 times 10 power negative 34 joule second. So divided by 6.63 times 10 power negative 34. The answer of this one, F naught, by using the calculator, it becomes 4.83 multiply 10 to the power 14 hertz. Question number 2. Light of wavelength is 350 nanometers. So the given is lambda. Lambda equals 350 nanometer. We convert to 2 meter, so multiply by 10 to the power negative 9 to be in meter. This is lambda. Okay, and the photoelectrons have maximum kinetic energy. Kinetic energy maximum equal 1.3 electron volt. What is the work function? So we need to get the work function. To get the work function, we need to get the energy of incident photon. The energy equals hc over lambda, because we have lambda. So the answer is 6.63 times 10 power negative 34 multiply the value of c. C is the speed of light, 3 times 10 power 8 divided by lambda, 350 multiply 10 power negative 9. From this we can get the energy. So the energy by using the calculator is 5.68 multiply 10 power negative 19 joule. Because the kinetic energy in electron volt, it's a good idea to change energy to electron volt. Now, from joule to electron volt divided by this value. So it's 5.68 multiply 10 power negative 19 divided by 1.6 times 10 power negative 19. The answer in electron volt, it is 3.55 electron volt. Okay, now the energy of incident photon, 3.55 electron volt. Now we have as a given the kinetic energy equals 1.3 electron volt, and now we calculate the energy of incident light, 3.55 electron volt. To get the work function and the threshold, the work function is phi. We can rearrange the equation. So phi equals E minus kinetic energy. Phi is the work function. E is the energy of incident photon, which is 3.55 minus kinetic energy maximum, 1.3. So the answer by using calculator is 2.25 electron volt. So this is the answer. Calculate the work function. So this is the work function of, what is the threshold of potassium? The work function, it's HF naught. So HF naught equals 2.25 electron volt. It's a good idea to change electron volt to joule. Remember, 1 electron volt, 1.6 times 10 power negative 19 joule. So from electron volt to joule, multiply. So it's 2.25 times 1.6 times 10 power negative 19. So the answer of this one in joule, it is 3.60 times 10 to the power negative 19 joule. This is HF naught. To get F naught, the threshold frequency, we divide by H. So it is 3.60 times 10 power negative 19. H equals 6.63 times 10 power negative 34 joule second. So we divided by 6.63 times 10 power negative 34. By using the calculator, F naught threshold frequency equals 5.43 multiply 10 to the power 14 hertz. Question number 3, a photo cell cathode is made with work function. So we have given the work function phi equals 2.8 electron volt. Wavelength 400 nanometer. So lambda equals 400 nanometer compared to meter, multiply 10 power negative 9 to be in meter. Will photoelectrons be emitted? Okay, the photoelectron will be emitted if the energy of incident function is if the energy of incident light is greater than the work function. Already we have the work function, so we need to get the energy of incident light. The energy of incident light equals hc over lambda, because we have lambda. So the energy of incident equals h 6.63 times the 10 power negative 34 multiply c speed of light 3 times the 10 power 8 divided by lambda in meter 400 multiply 10 power negative 9. The energy, by using the calculator, it becomes here 4.97 multiply 10 power negative 19 joule. Because the work function in electron volt, it's a good idea to change joule to electron volt. From joule to electron volt, what we do, remember, 1 electron volt equals 1.6 times the 10 power negative 19 joule. So from joule to electron volt divided by this value. When you divide this by 1.6 times 10 power negative 19, it becomes 3.11 electron volt. Now it's easy to compare. You note that the energy of incident light is 3.11 and the work function 2.8, so the energy of incident light is greater than the work function. So the photoelectrons will be emitted. Yes, photoelectrons will be emitted. Now, question number 6, work function of energy. Phi, work function denoted by phi. It's 4.3 electron volt. Show that the threshold frequency, we need F naught. What is the relation between the work function and the threshold frequency? It's easy. Phi equals HF naught. Phi equals 4.3 electron volt. It's a good idea to change it to joule. So we multiply by 1.6 times 10 power negative 19. 4.3 times 1.6 times 10 power negative 19. The answer in joule is 6.88 times 10 power negative 19 joule. Now this is HF naught, it's phi. So it's easy to get F naught divided by H blank constant. 6.688 times 10 power negative 19 divided by 6.63 times 10 power negative 34. The answer is 1.04 times 10 power 15 hertz. So it's approximately 1.0 times 10 to the power 15. Now the homework, you can solve exercise 9, page 171, 2020 edition. I hope you understand this lesson. Thank you.